I see myself in the darkness of my tablet, but also the window behind. Mirrors always show us something else than what we are looking at. Framed pictures may, under circumstances, show you quite another view than the depicted one. An ordinary mirror may seem simple, but it is an intriguing optical device. Here I have mounted one in an upright position on a table. An object on this side gives rise to its virtual counterpart, seemingly as far behind the mirror as the object is on our side. They hang together. What gives this optical illusion a character of reality is the fact that the position of the object is independent of the direction and position from which I observe it. If I move, it doesn't move. The logic of mirrors can be clarified by help of the wonderful science of geometrical optics. My visual intention is directed straightforward and can be symbolized by rays of sight. The mirror makes a deceptive impression of transparency. In reality, it is completely impenetrable for my sight. Instead, my view is redirected so that I see things behind or at the side of me. But how is that? The mirror can't influence my vision, can it? As a physicist, I prefer to discuss the issue not in terms of vision, but in terms of light rays, originating at the object and being reflected at the surface of the mirror according to the simple rule: the angle of reflection is the same as the angle of incidence. Some rays reach the eye of the observer. If the observer changes position, it doesn't matter. The rays entering his eyes will seem to originate at one and the same point, namely the point where the virtual object is localized for his sight. But this must be an illusion. What I see is actually the candlestick here on this side. Well, it is a bit more intriguing. I ignite the candle. Immediately the virtual candle behind the mirror is also ignited. I also reduce the general illumination of the scene. Now let us introduce a shadow-casting object. What is remarkable is that you get two shadows. One is casted in the light from the real candle, the other one in a flux of light apparently coming from the flame behind the mirror, shining right through it. Paradoxically, the virtual flame illuminates the scene from its position, as if we had to do with two flames. The basic principle of a mirror is that it makes itself invisible. You may prefer to call the candle behind the mirror an illusion, but from the point of view of optics, it is a virtual image and in a sense as real as the material one. You have a situation with two light sources, at some distance from each other, both sending out a flux of light. We could put a real candle there behind the mirror, exactly in the position of the virtual one. Take away the mirror, and optically it would be the same situation. So again, what is it I see? I see the radiant flame behind the mirror, not the one here beside me, or rather, I see both simultaneously. They are there, both of them, one shaped out of matter, the other one weaved of light. It is perhaps unsatisfactory not being able to see what is there in the space behind the mirror. Well, a mirror need not be opaque, as we saw in the beginning with the framed pictures. So let us use an ordinary window pane, like here. Nothing behind, until you see it from this side, then the virtual candle is there. Again, I ignite the candle and lower the room illumination. If I put the cork in place, we see only one shadow. The reason is that the reflectance factor of the glass plate is low. Hence we do not see the shadow casted by the light coming from the relatively weak virtual flame. This is the price we have to pay for transparency. But we can do something else. Let me turn the glass plate like this. Now the real candlestick can be moved to the side, even out of sight. Only the virtual flame is seen, ghost-like, on the other side of the window. In terms of geometrical optics, the situation is as follows. The real candle may be hidden, but still it can intermingle with the real objects in the world behind the window. Another application of the same idea is shown in this engraving. It is a trick to make a ghost appear on stage. I couldn't resist the temptation to try this out in reality, let be in puppet theater format. On the web, you can find hologram-ready videos with dancing figurines on black background. Here I have arranged a scene for a couple of them. Let them dance. Couldn't it as well be the case that you see mirror images of the two dancers in the polished black floor in front of the stage? On YouTube you can also find examples of a more advanced variant, namely a four-sided pyramid. It makes it possible to see the dancing figure from four sides. Again, a bit of geometrical analysis. The sides of the pyramid are sloping 45 degrees to the floor. In the ceiling you find the moving pictures of the figure. By adjusting positions you can make the figure stand at the center of the pyramid. How do I make such a holographic pyramid? First I have to measure the width of my screen. Half of it takes me to the center under the top of the pyramid. The height of this should have this same measure. Each side of the pyramid is a triangle with the following measures. Make a template in thin cardboard and use it to cut out the four sides from a thin sheet of polyester. After some constructing efforts, you have the mini theater. And so Luka can continue dancing. So again, what is it we see? We see the figurine in the transparent pyramid. If we try to go inside and touch her, she is not there. It is as with the rainbow, you cannot reach it. We do not see a lot of mirror images of the sun in the water drops forming the bow. No, we see the rainbow, a virtual entity. As such, it is objective, not a subjective illusion. The dancing figurine may have something to tell us with her dance, like the virtual flame behind the mirror, which could take part in a play of shadows on our side.